Some of you may recognize this image. It's the electromagnetic spectrum. Or is it? Take a look again. This is Netflix, ranked in the top 30 companies in the world by market cap, and with over 193 million paid subscribers worldwide. Over the past 10 years, they've completely revolutionized the entertainment industry. But how did they do it? Let's take a look at these four companies. Between them is over half the world's population. What do they all have in common? Well, what made them all wildly successful is their ability to use tons and tons of tabular data. What exactly is tabular data? Think of it like a business directory. Based off what products or services a business offers, it is categorized into different industries. Similarly, Netflix uses viewing data to determine what you're most likely to enjoy watching and to create compelling and award-winning Netflix originals to cement their competitive advantage. Tabular data is made up of two types. The first is continuous, and this is what we're used to, numbers like salary, age, etc. And then we have categorical data. This is where it gets a little more interesting. For selling a house, it would be what neighborhood it's in, what type of house it is. So is it a bungalow, a condo, or an apartment? And then finally, the type of property, residential or commercial. These are all discrete values that are related in some way to the final outcome, say the selling price. This is what got me interested in tabular data. I would check every day, again, and again, it would be closed. I've had a fascination with weather since I can remember, and so I figured that there must be a way to accurately predict when the canal will open year after year instead of having to manually check every single day. I found that there are many factors involved in ice formation and that the relationship is often hidden and very complex. The first one that comes to mind is obviously temperature. It has to be cold for water to freeze to ice. But snow also plays an important role that's hard to quantify. It insulates the surface and prevents ice from developing altogether. Compared to a day at -20 with 10 centimeters of snow on top of the canal, a day at -5 clear of snow is better for creating ice. So I set out to develop an AI model. I was able to access weather data going back over 50 years to 1970, the year leading up to the first skating season on the Rideau Canal. Then I had to make sure there was nothing missing, since tabular models need all the data filled, and I didn't want to simply replace missing values with normals. It took a lot of time to go through over 18,000 days of data. But surprisingly, there was no data missing in over 50 years until you got to last March, where over 3 months was missing. Wonder why? I was also able to verify in the code that there's no data missing after I had filled everything in. And then I decided to use a fairly large testing portion of data, about 30% of the total, to see how the model would be able to adjust to skating seasons that are now 20% shorter than they were 30 years ago. Then I understood how each piece of data correlated together with plotting them all in a heat map, and then eliminated all the unnecessary columns. After all that pre-processing, we're now ready to train the model. The first time around, I achieved an accuracy of around 89% after less than a minute, so not too bad. And as you can see, beyond one training cycle, the model did overfit for the training data. So it's time to iterate. With more research into best practices, I used the optimum learning rate this time around, and with only one training cycle, it's much better. We've got over 95% accuracy. Now, it's time to see how the model performs on brand new data. Over the last 15 years, it was 94% accurate in predicting on which days the canal would be open. What? That's insane. However, with tabular data, there's still a long way to go. For one, Amazon still recommends I buy books that I already own. 2 out of the 5 on the screen here. I'll let you guess which ones. And in the data, few features are often responsible for a large impact. And as a result, there's a ton of pre-processing work that needs to happen. And there are different units involved, such as days, months, or temperature. And data is often sparse, meaning that there can be little variation throughout the table. Moreover, for time series data like weather, you have to ensure that the data is fed in appropriately, either in sequence or randomly. For example, in the Rideau Canal model, the order of the training and validation data was completely randomized, whereas the final test set was fed in sequentially. However, this field holds tremendous promise. Together with image classification algorithms, tabular data has amazing applications, especially in medicine and business, and is most useful when multiple factors result in a certain outcome. Even in your own startup or with any structured data, if you can put it in a table, you can use tabular models to make predictions on it. Today, we're producing more structured data than ever before, whether it's shopping on Amazon, watching Netflix, or scrolling through Instagram and sending photos on Snapchat. Addressing the gap that remains in making sense of this data will unlock the potential in this emerging field of machine learning. For me, I'm especially looking forward to making my model into a fully fledged prediction tool using an integrated API available online. and to continue to explore the applications of this underrated domain. Being able to effectively model complex systems and learn the nuances of weather so quickly, this field holds tremendous promise for the future. Thank you.